Algebra 1 Common Core. This is the June 2016 Algebra 1 Regents exam, starting at number 12. The previous videos covered 1 through 6, I believe, and then, or 1 through 5, and then 6 through 11. So here we're going to pick up on number 12. So the zeros of the function x squared minus 5x minus 6 are what? So a couple of ways you could do this. We could do this with just pure factoring. This is a quadratic. I see that because the highest exponent is x squared. And so if I use factoring, where I can set the function equal to 0 and factor, I'm looking for the numbers that add to negative 5 and multiply to negative 6. That's going to be x minus, x minus 6, x plus 1. Will that multiply to negative 6? Yes, they will. Will they add to negative 5? Yeah, I think a lot of people would probably try to use 2 and 3 here. But the fact that they got to multiply to negative means they got to be different signs. And if they're different signs, they're not going to add to negative 5. They would either add to 1 or negative 1. So that's not going to be the case. But remember, these are the factors, not the roots, not the zeros. The zeros come from when you solve them. So you have to take x minus 6 and set it equal to 0. I'm sorry, these little boxes pop up. It's annoying. And then now I can't get it to go away. See, will that work? Kind of. X minus 6 equals 0. Go back to my pen here. X minus 6 equals 0. X plus 1 equals 0. Add 6, and we end up with x equals 6. Minus 1, x equals negative 1. And so the zeros, or the roots, are 6 and negative 1. Positive 6, negative 1. So choice A. Now, your calculator could help you here. If I were to take a look and type this function in the y equals utility in my calculator, like y equals x squared, I already have in there, but let's change it to minus 5x minus 6. And if you look at the graph, you'll see it's crossing at negative 1 and positive 6. Those are your zeros. Those are your roots. But you could also see it from the table perspective that next to negative 1 you have a 0 next to it, and that's why they're called zeros, because they have y values of 0, and next to 6 we have a 0 next to it. So your calculator can get these answers for you, but really it comes from factoring, and factors turn into zeros. Number 13. In a sequence, the first term is 4 and the common difference is 3. Find the fifth term. So common difference is a phrase that is reserved for the arithmetic sequence. And on your Regents reference sheet, which is probably the last page of this slide, let me see, I'm on 14 right now. No, it didn't get put on here, but it is on your Regents reference sheet, an arithmetic formula of a sub n equals a sub 1 plus n minus 1 times d. And we got to just kind of plug in the things we need here. So we're told that the first term is 4. That's what a sub 1 is. The common difference is 3. And we want the fifth term. The fifth term, the term that you're working with, is your n value. So if we want our fifth term, we're looking for a sub 5, which means n equals 5. So it's like 5 minus 1. So that's going to be 4 plus 5 minus 1, of course, is 4 times 3. 4 plus 4 times 3 is 12. 4 plus 12 is 16. I think some people would probably go the lazy way of saying, all right, the first, second, third, fourth, fifth term. The first term is 4, and the common difference is 3. So that means a plus 3 pattern. Remember, this is a linear pattern with a slope of 3. So plus 3, plus 3, plus 3, plus 3. There we go. And sometimes that's the easy way to do it, but you really do want to get very good and very familiar with this formula and how to use it, because there are problems that really call for it. Number 14. The growth of a certain organism can be modeled by C of t, which equals 10 times 1.029 raised to the 424t, where C of t is the total number of cells after t hours. Which function is approximately equivalent to C of t? Which is kind of a weird exponential problem. Now, first of all, I'm calling it exponential because the variable t, which is replacing x, right? It's not f of x, it's c of t, is in the exponent, so we know it's exponential. And exponential growth, it's a curve, it's not a line. I mean, I want to say the cheater way, but it's not cheater. It's probably the smart way of doing this is, type this into my calculator, and then I could compare it to these and see which one is approximately equivalent. I'm looking for something that's basically going to have the same graph, the same curve. So I don't, that's probably what I would do. But if we look at these choices, let's see if I could come up with my guess here. So if the exponent's not going to change, changing your base, and this, first of all, this is exponential growth. So the base has to be greater than 1. So these 0.83s, where your base is less than 1, that's exponential decay. So that doesn't really make a whole lot of sense to me at all. So it's either going to be C or D. And what's the difference here? Well, instead of 24t, we just have t. Instead of 24t, we have t over 24. So what would change our base? So the base right now of 1.029 being raised to the 24t, that's the same thing as 1.029 being raised to the 24 and being raised to the t. So I could kind of just figure out what this 1.029 raised to the 24 is. Let's try that. And let's see if it comes out to be 1.986. So we have 1.029. Get out of there. 1.029 raised to the 24th. That is 1.9859, and that's what we were looking for. That will round to that value. So by changing the base raised to 24t just to t, basically applying that exponent of 24, and that's what this is going to be. Like I said, I think maybe even an easier way to go about this, because they want to know which of these are equivalent, type them in and match them up. Which one gives you pretty much the same graph. The reason why they say approximately is because they did end up rounding that off a little bit. And so it's not going to be exactly the same curve, but it's going to be pretty much the same thing. If you type those two functions into your y equals, you'll see the same picture. Number 15. Public opinion was taken to explore the relationship between age and support for a candidate in an election. The results of the poll are summarized in the table below. So what we call a two-way table, because we have kind of two variables here, age and then, in this case, opinion. What they don't do here is give you totals, right? So we want the total that are for, total against, total no opinion, total this way, total this way, total this way. I mean, sometimes you can read the problem and kind of skip to the total you need. The total of everybody, how many people were asked. And if it wants the, percentage of everybody, but here it says what percent of the 21 to 40 age group. So that means out of the 21 to 40 age group. So what's the total for 41 to 80? 30 plus 12 is 42, plus 8 is 50. So there's a total of 50 in this age group. Out of those 50 people, how many were for the candidate? 30 out of 50. And what percent is that? Well, the way we get percentage from a fraction is you simply type in the top divided by the bottom. So 30 divided by 50 gives you 0.6, and then if you times it by 100, you can clearly see what the percentage is. That is 60%. I think most people could probably just recognize 0.6 is 60%. That's it. So, you could have gotten all the totals here, and the total here, but this one question had one specific, it was just looking in that category, so save ourselves a little bit of time. Number 16. Which equation and ordered pair represents the correct vertex form and vertex for this quadratic? So the way to do vertex form, first of all, we could do this with a calculator or we could do it algebraically. Because it's multiple choice, there's nothing wrong with the calculator. Again, notice that they give me kind of two options here. But let's type this into our calculator. X squared minus 12x plus 7. So y equals x squared minus, oops, sorry about that. X squared minus 12x, and I forgot, what is it? Plus 7. Plus 7. And let's take a look at the graph. It's going to be a positive parabola, smiley face. Looks like I'm kind of missing some of it here, and I could obviously change my window to see that. But let's look at the table to see if we can kind of see where the vertex is. Where does the pattern start to change for this thing? I'm looking at it. Looks like it's right there. You see how it goes 25, negative 25, negative 28, negative 29, and then it changes back to negative 28, negative 20. So 6, negative 29, right there, where the change happens, the one number that's not repeating. It's not always visible in the table, but it's a good place to look. That's the vertex. So 6, negative 29. So anything that doesn't have that vertex is not the answer. Right away, we're done. But the other thing is we can type in these, x minus 6 squared minus 29. Let me see that. So if I type that in also in y2, so parentheses, x minus 6 squared, and it was minus 29. What I'll notice on the graph is I'll only see one graph, but on the table you'll also see that the columns are exactly the same because it is the same equation, just expressed a different way. Now, how do we do this if it's not a multiple choice question? How do we do it algebraically? What if it's a part 2? Well, what we do is we first set the equation equal to 0, and then we do the process of completing the square, but not all the way. The first step in completing the square is move the constant. So move that to the other side. So minus 12x equals negative 7. Then we add something on both sides. And the way we get that term we add to both sides is from that little, b divided by 2 squared thing. Your b term is negative 12. Divide that by 2, you get negative 6. Square it to be 36. 36. Factor this one. It factors to x minus 6 and x minus 6. So we write it once as x minus 6 squared. And just clean up these like terms. That's going to be positive 29. Now, if we were continuing to solve, we would square root both sides, do plus minus. But that's not what you stop here at vertex form. Well, at least you stop completing the square. But then you reset it equal to 0. So we got to bring this 29 back over. So we got a minus 29 on both sides to get it all on one side. And that just goes after the parentheses. So minus 29. Instead of equals 0, I'll do a y equals or an f of x equals. And that's what you see here. X minus 6 squared minus 29. And the vertex we got from our calculator. So we knew the answer before we even really started doing much of the math. All right, we're approaching 13 minutes, so I'll stop here. And the next video will probably come close to finishing the part 1s. See ya.